Good day. I am Dr. P.K. Esnan from Department of Mechanical Engineering at Galgotias University. Today I'll talk about engineering mechanics, which I am teaching in third semester with course code BTME 2001. We will be talking about the basics of engineering mechanics today, and I will be taking you through some important laws which will be very useful in understanding and laying the foundation of engineering mechanics problem. Coming to today's lecture objectives. Lecture objectives or learning objectives are the objectives which will be met during this lecture. So what I am trying to make you learn in this lecture is, as I am discussing now, we will try to understand the basic laws of mechanics. We try to understand the law of transmissibility of forces. Then we will go to the vector laws. We will try to understand the law of superposition, and then we will define parallelogram law of forces. We will also understand triangle law of forces, and in last we will try to extend it to polygon law of forces. So these are the 6 major learning objectives of today's lecture. We will begin with Newton's first law of mechanics, and the Newton's first law of mechanics, as we all know since our high school days, is popularly known as law of inertia. So the law of inertia, what does it say? The first law of Newton's first law says that every body continues in the state of rest or in the uniform motion in a straight line in absence of external agency acting on it. What is external agency? External agency means any force which is external to the body. If it is acting on the body, only then the body will try to change its course. Otherwise, it will continue in the straight line. If it is at the rest, it will stay in the rest. If it is moving, it will uniformly move in the same direction with the same velocity. But contrary to this, we see if I roll a ball on the floor, I'll find it will start slowing down after certain rolling, and it comes to rest. What is making any what is making in the change in the speed of the ball which I have thrown? So basically the answer is, on this ball the external agency is acting. Which external agency is acting? The frictional force is the external force which is acting on it and which is opposing the motion, and hence it is slowing down. In absence of friction, of course, it will continue with the uniform velocity for infinite time. So we should understand that when we are referring external agency in this lecture, we are talking about the external force. And as I stated earlier, it is popularly known as law of inertia. Then we come to Newton's second law. In Newton's second law, is very simple. It says that what happens if the external force acts, external agency or external force acts on the body. So if in case the external force or external agency is acting on the body, the rate of change of momentum of body is directly proportional to the impressed force, and it takes place in the direction of force acting on it. So if we see mathematically, it is saying the force F, which is external to the body, is proportional to rate of change of linear momentum. And what is linear momentum? M into V. So rate of change of linear momentum is directly proportional to the external force. And if you see, if force is acting, the force is a vector quantity, it acts in a direction, and hence this rate of change of linear momentum will be in the direction of the force acting on it. Okay, so that is also important. So this is the second law, that F is proportional to d by dt of the linear momentum, and the change in the linear momentum takes place in the direction of the force which is external and acting on the body. If the body's mass is constant, I can take it outside the differential d by dt, and I can write it in a second line like this: F is proportional to m times d by dt of velocity alone, not the linear momentum, because mass is constant. So it can safely come out of the differential, and it will become m dv by dt. Now, rate of change of velocity we all know is known as acceleration. So in the next simplification, I simply say F is proportional to mass times acceleration. And if I introduce the constant of proportionality k into 8, F becomes equal to k times m into a. What is k? K is the constant of proportionality. And we have to remember that we are using in this course the SI system of units, in which the value of the proportionality constant above k is 1, and hence we simply say force is equal to mass times acceleration, or F into ma in our classroom teaching and for problem solving, because internationally it has been agreed now that we need to have a uniform system of units. SI system of units has to be used. Then we come to the Newton's third law of mechanics, and for Newton's third law of mechanics we say that for every action there is equal and opposite reaction. So look at the ball which is resting on a blue table top. Now if I slightly move this body above and try to show the forces which are acting on these bodies, hypothetically I am separating them as individual body. Actually they are touching each other. So the ball I have slightly shown above the top, and I show the blue tabletop is putting blue reaction on the ball, and what the ball is trying to push the with its weight, because it is resting on the blue tabletop. So the action is the downward vector force equal to the weight of the ball. So equal and opposite is the reaction applied by the tabletop on the ball. So in order to different action and reaction, I have used the different colors, and basically they are balancing, they are in line with each other. So their magnitude and line of action to be same in order to have the equilibrium, and hence we can say action force should be equal to reaction force, and that is Newton's third law of motion. Newton's law of gravitational forces. So we all experience that there is a gravity force which pulls us towards the earth. Similarly, if the two celestial bodies are far apart from each other, they pull each other also with some force of attraction, and that is known as Newton's gravitational forces. Newton was the first to identify it and prove it. He said that every body attracts the other body. The force of attraction between any two bodies is directly proportional to their masses and inversely proportional to the square of the distance between them. Like if we have two bodies, one is having mass m1, other one is having mass m2, they both will attract each other with force F. The distance between the center of gravity of these two bodies is d, as shown in the figure. So the Newton laws say the force of attraction F is proportional to the product of mass m1 and m2 divided by inversely proportional, that means divided by the square of the distance d square. So if that is proportionality, and if we convert it into inequality, we can write the same law as F equal to capital G m1 m2 upon d square. So capital G is known as constant of proportionality and is known as constant of gravitation, and the value of G is 6.673 into 10 to power 11 Newton meter square per kg square. So this is Newton's law of gravitational force. I want to clarify here that basically if we are talking of the small bodies which are we are encountering in our day-to-day life, the force of attraction is very small because their masses are very small. But if you talk about the celestial bodies like Earth and Sun, their mass is quite large, though the distance is also very large, but the mass is huge. Then this force of attraction plays a vital role between these bodies, attraction of between the Sun and Earth, and because of this gravitational force pull, Earth circulates in a orbital path around the Sun. So the force which is controlling that is this Newton's law of gravitational force, which defines that force. So this has to be understood, that it is important for celestial bodies, though it is also applicable to the normal bodies which we are encountering in day-to-day life, but that value of F is very small in magnitude, hence we are unable to feel it. Now we come to the vector side of the engineering mechanics, and in vector side of engineering mechanics, if you see, the first thing is how the vector should be added. The first one was the law of parallelogram of forces, which defines how the forces are to be added. So let us take two forces, one is F1 with blue vector and F2 with yellow vector. Both of the vectors are making an angle theta with each other as shown in the figure. So what we will do, we will draw a line parallel to F2, which is another yellow vector I have shown here near the ledger pointer, and we draw a parallel line from end of F2 in blue color, and it completes our parallelogram. So the diagonal would be the resultant of these forces F1 and F2, and that would be inclined with F1 at an angle alpha. So this is law of parallelogram of force. So you see we have made a parallelogram from two forces F1 and F2, and the diagonal is giving me the resultant in its direction. The same can be stated in terms of text like this: if two forces acting at a point be represented in magnitude and direction by two adjacent sides of parallelogram, like blue and yellow vector which I am showing here, two adjacent sides of parallelogram, then their resultant R, black vector, is represented in magnitude and direction by diagonal of the parallelogram passing through that point. So this is law of parallelogram of forces. Next is the law of triangle of forces. It is, if you see, I have just removed this F2 which I have shown here, but I have moved the F2 force, yellow vector, from the tail of the vector F1 to the tip of the vector F1. And if you see, now F1 is the ending at the arrow part. So from there I will start drawing the another vector F2, and the closing side of the triangle taken from the tail of the F1 to the tip of the F2 vector will be the resultant vector R, and it would be inclined at angle alpha. So this is known as triangle law of force, and it states that the two forces acting at a point are represented by the magnitude and direction taken in order. Then the closing side of the triangle takes from the starting point to last point represent the resultant force. So F1 and F2 are taken in order, then the closing side taken from the first point to the last point represent the resultant force and angle. If you look carefully and if you go back to the previous position, you will find the parallelogram would be nothing but this closing this parallelogram will give you the same result. So it is not the parallelogram. We have just stated the law of parallelogram forces in slightly different language as a triangle, but both of them will give you the same results. Then we will have a law of polygon of forces. So Polygon law of forces says that if you have multiple, so far we were dealing with only two forces, but now if you are dealing with multiple forces, F1, F2, F3, F4, taken in order, so that F1 starts here, ends at here, tip, then F2 starts from the tip of the F1, and then here the F3 similarly starts from where F2 is ending. So if you join the forces in this order, then the closing side of the polygon will give you the resultant R, and that is very simple to understand. If you try to extend the law of triangle of forces, you can easily prove the Polygon law of forces. So the Polygon law of forces states that any number of forces acting on a point are represented as per magnitude and direction in the correct order. Then the closing side from the starting point of first force to the last point of the last force represents the resultant force. This is known as Polygon law of forces. Now, to summarize today's lecture, we have studied Newton's law of basic mechanics, and so the engineering mechanics is always obeying the Newton's basic laws which we discussed, and the law of vector addition we have already studied that a law of vector additions are followed by the vector quantities. So now the question for today is, try to derive the Polygon law of forces as an extension of triangle law of forces, that take multiple triangles one by one and try to prove that the law of Polygon forces is nothing but an extension of triangle law of vector addition. To finish the textbooks of this course, we have Engineering Mechanics by Bhavi Katti and the Engineering Mechanics by Bansal as the textbooks, and the reference books are given as Rao, Young, and Beer and Johnson, Beer and Russell, and this Irving H. Shames. So these books are a good reading reference for the topics in detail. So that's all for today. Thanks a lot and happy learning.